Welcome to our channel. Today we're diving into the mysterious world of Mercury, the closest planet to the Sun. Get ready for some mind-blowing facts. When you think about it, Mercury is a bit of an enigma. It's small, rocky, and blasted by the Sun's intense heat. Yet it holds many secrets that pique our curiosity. Over the next few minutes, we'll uncover some of these strange and fascinating truths about Mercury that will leave you questioning everything you thought you knew about our cosmic neighbor. You'd think the closest planet to the Sun would be a scorching inferno, right? Well, Mercury likes to play by its own rules. Believe it or not, scientists have found evidence of ice on this seemingly inhospitable world. Now, you won't find any ice skating rinks on Mercury. This ice is tucked away in permanently shadowed craters at the planet's poles. These craters are like cosmic refrigerators, shielding the ice from the Sun's relentless rays. It's a testament to the universe's ability to surprise us, hiding ice in the most unexpected places. Time on Mercury is, well, let's just say it's relative. Picture this: a day on Mercury is longer than a year on Mercury. How is that even possible? Here's the breakdown. It takes Mercury a sluggish 59 Earth days to complete one rotation on its axis. That's one Mercurian day, but it only takes Mercury a mere 88 Earth days to orbit the Sun. That's one Mercurian year. So if you lived on Mercury, you'd celebrate your birthday every 88 Earth days, but you'd only experience one sunrise every 59 Earth days. Talk about a mind-bending concept of time. When it comes to atmospheres, Mercury seems to have missed the memo. Our planet is cloaked in a life-giving atmosphere, a shield against the harshness of space. Mercury, on the other hand, has an atmosphere so thin that it's practically non-existent. We're talking about an atmosphere that's closer to a vacuum than anything we experience on Earth. It's composed mostly of oxygen, sodium, and hydrogen, but these elements are so spread out that they barely interact. This lack of a substantial atmosphere explains why Mercury is riddled with craters. There's no air to slow down incoming space debris, so it slams into the surface with full force. Chapter 4. The Solar System's Punching Bag. If planets had a history of getting into cosmic brawls, Mercury would be the most battle-scarred of them all. This small rocky planet, closest to the Sun, has been a target for countless cosmic projectiles. Its surface is a testament to the relentless bombardment it has endured over billions of years. Each crater tells a story of an impact, a collision that shaped the planet's rugged landscape. We're talking about craters, and lots of them. From tiny pits to massive basins, Mercury's surface is a mosaic of these impact scars. Mercury has more craters than any other planet in our solar system. This is due to its proximity to the Sun and its lack of a substantial atmosphere. These craters range in size from small, pockmark-like depressions to vast impact basins hundreds of kilometers across. Why so many craters? The answer lies in Mercury's unique position and characteristics. Well, remember that wisp of an atmosphere we talked about? Mercury's atmosphere is so thin that it offers little to no protection against incoming space debris. It offers little to no protection against incoming asteroids and comets. These space rocks, traveling at incredible speeds, strike Mercury's surface with tremendous force. Every cosmic projectile leaves its mark on Mercury's surface, creating a celestial tapestry of impacts. Over time, these impacts have accumulated, giving Mercury its distinctive, heavily cratered appearance. The history of these impacts is a window into the early solar system, revealing the chaotic environment in which Mercury and its neighboring planets formed. Each crater is a chapter in the story of our solar system's violent past. So, next time you look at Mercury, remember that every crater is a reminder of the countless collisions that have shaped not just this planet, but the entire solar system. Chapter 5. A Giant Heart of Iron. Don't let Mercury's small size fool you. This planet has a heart of iron, and a massive one at that. Despite being the smallest planet in our solar system, Mercury's core is disproportionately large. Proportionally speaking, Mercury has the largest core of any planet in our solar system. This core is not just large, it's colossal when compared to the planet's overall size. It's a solid iron core that makes up a whopping 85% of the planet's radius. This means that the core dominates Mercury's internal structure, leaving very little room for other layers. To put that into perspective, Imagine if Earth's core took up almost the entire planet, leaving a thin shell of mantle and crust. On Earth, the core is only about 15% of the planet's radius, making Mercury's core truly extraordinary. That's Mercury for you, a planet that's essentially a giant ball of iron with a thin rocky coating. This thin crust is all that remains of what was once a much larger planet. Scientists believe this massive core formed early in Mercury's history, possibly due to a giant impact that stripped away much of its outer layers. This cataclysmic event would have left behind the dense, iron-rich core we see today, making Mercury a fascinating subject of study for planetary scientists. Chapter 6. Magnetic Twisters in Space. We've all heard of tornadoes here on Earth, but have you ever imagined tornadoes of magnetism swirling through space? Well, Mercury has them. These aren't your typical wind-driven tornadoes, of course. These are magnetic tornadoes, also known as flux transfer events. They form when Mercury's magnetic field interacts with the solar wind, a stream of charged particles constantly flowing from the sun. Imagine these magnetic tornadoes as twisting ropes of magnetic energy, connecting Mercury's magnetic field to the sun's magnetic field. They're a fascinating example of the complex interactions that occur between planets and their stars. Chapter 7. From Oven to Freezer and Back Again. If you're looking for a planet with extreme temperature swings, look no further than Mercury. This small, rocky planet, the closest to the Sun, is a world of stark contrasts. This planet experiences the most dramatic temperature variations in our solar system. The temperature difference between day and night is nothing short of extraordinary. During the day, when the sun is blazing overhead, temperatures on Mercury's surface can soar to a scorching 427 degrees Celsius, or 800 degrees Fahrenheit. Imagine standing on a surface that hot. That's hot enough to melt lead. The intense heat is a result of Mercury's proximity to the sun and its slow rotation. But as soon as the sun sets, temperatures plummet to a frigid minus 173 degrees Celsius, or minus 280 degrees Fahrenheit. The night on Mercury is as cold as the day is hot. This extreme temperature difference is due to Mercury's lack of a substantial atmosphere to regulate heat. Without a thick atmosphere, there is nothing to trap the heat during the night. So if you ever find yourself on Mercury, pack both your swimsuit and your parka. You'll need the swimsuit for the blistering days and the parka for the freezing nights. It's a planet of extremes, where survival would be a constant challenge. Mercury's elliptical orbit also contributes to its temperature extremes. At its closest approach to the Sun, known as perihelion, the planet receives even more intense solar radiation. Despite these harsh conditions, Mercury remains a fascinating subject of study for scientists, offering insights into the formation and evolution of our solar system. Chapter 8. Most planets go through a growth spurt in their youth, but Mercury seems to be going through a midlife crisis. It's shrinking. Over billions of years, Mercury has been gradually cooling and contracting. As its molten core slowly solidifies, the planet is essentially crumpling inward. This contraction has caused Mercury's surface to wrinkle, forming cliffs, ridges, and scarps that stretch for hundreds of kilometers. Imagine a grape slowly shriveling up into a raisin. That's a simplified way to visualize what's happening to Mercury. It's a reminder that even planets aren't immune to the effects of time and the laws of physics. Chapter 9. You might think of comets as icy wanderers with long flowing tails, but Mercury has a secret. It has a tail too. Now, Mercury isn't about to sprout a tail of ice and dust like a comet. Its tail is much more subtle. It's a stream of sodium atoms that extends for millions of kilometers behind the planet. This sodium tail is created by the solar wind constantly bombarding Mercury's surface. The solar wind's charged particles knock sodium atoms off the planet's surface, sending them out into space in a long trailing tail. Chapter 10. Long before telescopes and space probes, humans have gazed up at the night sky and wondered about the cosmos. And even in ancient times, Mercury didn't escape our attention. Ancient civilizations, including the Greeks and Romans, were well aware of this tiny planet darting across the sky. They named it after Mercury, the swift-footed messenger of the gods, because of its rapid movement across the celestial sphere. Mercury's appearance in ancient mythology reminds us that our fascination with the cosmos is deeply ingrained in our history and culture. Thanks for watching. If you enjoyed these strange facts about Mercury, don't forget to like, subscribe, and hit the bell icon for more amazing content. See you next time. From its hidden ice to its shrinking size and magnetic tornadoes, Mercury is a planet full of surprises. It's a reminder that our solar system is full of wonders waiting to be discovered. So the next time you look up at the night sky, take a moment to appreciate the tiny planet Mercury and all its strange and fascinating secrets.